Hey everybody. So today we're going to be talking about amino acid disorders. So first and foremost, I wanted to go over the basics. As we all know, amino acids have their normal name. Can I remove this? Quiet video panel. Unfloating meeting controls. That's not called. Hey everybody. So today we're going to be talking about amino acid disorders. So first and foremost, I want to go over some basics. I loved our little chart that we had at the beginning of our amino acid PowerPoint, so I made my own. As you can see, Teddy is for tyrosine, Miles is for methionine, Timothy's for isoleucine, Vader's for valine. I just thought it was a really cute idea. I did not have any animals with Y and Q, so I did my best. Anyway, every amino acid has an alpha carbon, and attached to this alpha carbon are 3 to 4 different groups. You can have one hydrogen at least. You have a carboxyl group, which is negatively charged in neutral solutions. You can have an amino group, which is positively charged in neutral solutions. And then you have an R group, which is the variation between the amino acids. So the R group allows them to be put into different classifications, which is what we're going to talk about now. You can have essential versus non-essential. Essential is the ones where you have to eat them for them to be in your body, and non-essential are the ones that you can synthesize from what's already in your cells. So you have acidic, basic, neutral, aromatic, sulfur containing. And those, I thought that little chart was really cute up in the top left-hand corner. It just shows you color coded all of the different amino acids and their classifications, and then you can classify them based on where they go in your body and what they get degraded down into from proteins. Um, and as you can see, the glucogenic ones are the ones that go in the citric acid cycle. The ketogenic ones are the ones that go into ketone bodies. You can be both. Mostly they're going to be glucogenic though. So to start off with, we're going to have phenylalanine and tyrosine disorders. So starting off strong, we got PKU. Just some random facts. It was discovered in 1934. It causes an intellectual disability and it can cause an unusual odor. I thought that was very interesting. The majority of cases are caused by the enzyme phenylalanine hydroxylase. So I know this slide is blurry. I promise I did everything I could. But if you want a clearer picture, it's on slide 41 of the urea cycle and amino acid catabolism PowerPoint. But it basically shows how phenylalanine is converted to tyrosine using phenylalanine hydroxylase and O2 and water. So if you have PKU, that step stops. So you have an accumulation of phenylalanine and not as much tyrosine. Phenylalanine is essential, so you're eating it. And tyrosine is semi-essential, meaning you can synthesize it, but you also need some. And if all your phenylalanine is just staying phenylalanine and none of it's going to tyrosine, that can cause some problems because you're not going to make all the proteins that require tyrosine. So this brings us to our first quiz question. Why would a problem with phenylalanine hydroxylase cause a learning disability? I want you to use 2 to 4 sentences, and your little hint is going to be to think about the role of phenylalanine and tyrosine and like what they do in the citric acid cycle, what they form and what forms in the citric acid cycle. And with learning ability, I want you to think about brain food. What in the citric acid cycle makes brain food? So that should get you started on the right track. And I just want 2 to 4 sentences about that, quick and easy. Nothing too bad. So now we're going to talk about orders to do with the deficiency of 4-hydroxyphenyl pyruvate deoxygenase. As you can see up at the top, we got PKU, already covered that one. So now we're going to talk about tyrosinemia type 2. This is thought to be caused by an immature 4-hydroxyphenylpyruvate deoxygenase. That's not confirmed, and you can diagnose with elevated levels of tyrosine in the plasma, but this is not good either because then it causes an accumulation of tyrosine instead of an accumulation of phenylalanine like PKU does. But both are bad. You want the end products of this chain reaction. You don't want just phenylalanine and you don't want just tyrosine. So because it's stopping here, you're not going to get the good stuff like the fumarate or the acetoacetyl-CoA that you get at the end of this pathway. So it also causes intellectual disabilities. All of these really cause intellectual disabilities, to be quite honest with you. So if we make it through tyrosinemia type 2, then we go to tyrosinemia type 3. This is again caused by 4-hydroxyphenylpyruvate deoxygenase enzyme, but this is caused by the pathogenic variant of the enzyme. So tyrosine in these metabolites are in elevated levels in the blood and the urine. So, excuse me, we've made it out of the plasma and now we're in the blood and urine, but we still can't get rid of it, right? Because we're still at elevated levels. We're still not able to make it through this pathway correctly. And now we're going to get to tyrosinemia type 1. This is the very last step in the degradation of tyrosine. It's caused by pathogenic variants in the FAH gene, and this gene is what encodes the enzyme fumarate acetoacetate. Maybe I pronounced that right. I'm not really for sure. But precursors and byproducts start to accumulate, causing toxicity in these cells because they're not getting used up. They're byproducts. They're precursors. They're not what we need. We need the fumarate and acetyl-CoA. We don't need these precursors and byproducts. We want the fumarate and the citric acid cycle food, which we're not getting if we don't completely degrade phenylalanine and tyrosine. So that pretty much wraps us up for our phenylalanine and tyrosine disorders. So now we're going to move on to our branched chain amino acid disorders. So branched chain, think valine, isoleucine, leucine. These are the ones that we're going to be covering for this disorder. The big one for this one is maple syrup urine disease. It's caused by problems affecting the branched chain alpha keto acid dehydrogenase complex. And as you can see, this is what takes all of these amino acids into the mitochondria. So again, bad. We don't want this. And as you can also see, all of these intermediates or the end products go to the citric acid cycle. So again, we're not giving the citric acid cycle what it needs to run if we have these disorders, because these amino acids aren't breaking down correctly. And again, maple syrup urine disease causes intellectual disability and premature death in infants. So this brings us to our second and final quiz question. So there's two other branched chain amino acid disorders that I didn't go into before. They're hypervalinemia and hyperleucine isoleucinemia. Maybe I pronounced that one right, which are caused by problems with branched chain amino acid transaminase 1 and 2, which can be treated with vitamin B6 supplements. So I want to know why you think that is. And I want you to use 1 to 3 sentences, and a little would be to think about the role of vitamin B6 in branched chain amino acid reactions. I would recommend you go back and look at the PowerPoint because it kind of spells it out really well for you. So this brings us to our sulfonated amino acid disorders. We're really hitting all the high points. We went to branched chains, now we're on sulfonated. So this big one is going to be homocystinuria. This is the defective enzyme is cystathionine beta synthase. Sorry, it's just such a mouthful. So this is when methionine doesn't degrade and doesn't degrade down into cysteine. So not good for making proteins. And the homocysteine and methionine levels are very highly regulated in the system. So like if there's a high level of methionine, homocysteine, more homocysteines are going to be made. So this is highly regulated. And if there's not any methionine breakdown, then the levels are going to be all out of whack, and it is just not good for anybody. Again, this causes intellectual disability and premature death. So now this is our last one. We have glycine encephalopathy. Ooh, Okay, so glycine accumulates in the spinal fluid as well as other body tissues because it's not being broken down properly. It causes severe intellectual disability and it can be diagnosed based on an elevated ratio of cerebral spinal fluid to plasma glycine. So sodium benzoate can treat it because sodium benzoate forms a complex with glycine to make hippuric acid, which can then be transported out of the cell to get glycine levels down. And this is just my cat because I've been talking a lot about intellectual disabilities, and I have a cat that looks like that, but she does not have glycine encephalopathy. She is just silly goofy. So that is all I have for you. Thank you so much for listening, and I hope you have a wonderful day.